Record on this computer. Okay, I think we're recording now. I hope that'll work. Pause recording, stop recording.
Link to this.
Was it posted in Discord or not?
It's the most recent one announcements. Yeah, that one's still there.
I'll sit in discussion. So this is my Zoom room, which is ufl.zoom.us. I'm pretty sure that's accurate. If it's not, it's very similar to that, and someone else can kind of correct it from there. Okay. All right, showtime too. Okay, so this is an advanced Git workshop, and by advanced, what I really mean is not beginner.
Actually, let me try that.
It's for that, yeah. So this is probably more intermediate stuff, right? This is you've gone through Git, you know.
That was screen feedback. By the way.
And so you've gone through some of the Git stuff, right? You've done like add, commit, push, right? Really about all that type of stuff. You've probably pulled down a repository. You may have made a couple PRs. Hopefully you've created a branch or two and are kind of familiar with that. If you're not, then downstairs is probably better for the simple reason of we're going to breeze through all of that stuff and then go to some kind of like object model stuff. If you're missing that kind of foundation, it'll be hard to kind of jump in. Any type of workshops like this are always generally kind of hard because everyone's kind of at a different point with things. So the only options are to start from base one, which is not valuable to a lot of people, or to start somewhere in the middle, which can get a bit messy. But we'll do the best we can. Okay, so we're going to talk about two main things, right? Actually, I have an agenda right here. Perfect. Okay. So, and I'm missing bullet point. That's trailing. Nice. Okay, so part 0 is just going to be a quick Git recap, right? All the core things that we need to know. Then part 1 is just going to be the Git workflows, right? This is basically how you use Git with software engineering, what like Git stuff looks like, because you have things like branches that matter and other things. And then we're going to dive into 2 workshops. One that's about history primarily, and then the other that's about merging, right? Okay. So Git recap, talking about. So Git 101. So Git is a distributed version control system, right? It's distributed because you don't have to communicate with the central server. You can talk with everyone. In practice, we really don't care about that too much. We pretty much just always use GitHub for most things. That tends to be how we do things. But there are other options. So you should be familiar with command line stuff. So things like git status, diff, log, add, commit, push, pull, as well as some branches and kind of basic merging things. Great. So if I ask you to merge a branch, then please don't freak out on me. Okay. So there are a couple different ways to kind of structure branches, but we really kind of narrowed down onto one that actually kind of works. So Git is kind of impressive because it's like the only version control system that somehow became like actually standardized. There's some others that are in use. I think SQLite uses a thing called Fossil. The other one is SVN, which you might have heard of. But pretty much everyone uses Git for things, and Git flow is pretty standard within that as well. And so this is, I think, called GitHub flow. So I'm presenting this first because it's a simpler model, and then we'll look at actual Git flow. And so the basic idea is that you have some type of master branch, right? Something that is the primary, track of development. And then you create branches off of that to do whatever other features and other things that you need. So here we have a bug fix branch that kind of just comes into play, does a couple commits, and then it goes out of play. And then we have a feature branch that does the same thing. And you can see these are kind of intermingled between each other, right? These branches are separate tracks of development, and we can work, thanks to Git primarily, in order to make sure that these are not kind of tripping over each other as we do separate tracks of development and then combine them all together in the end, right? So this is kind of the key idea with Git. Now, you'll see that there's a couple other different commits here, right? So like this one here in the center where feature is coming off of, this is kind of a commit that appears to just kind of be directly on the master branch. In practice, you try to have kind of one track of development, one branch where you don't actually make any direct commits to it, unless it's like really unique stuff like, infrastructure things that you don't have another choice to. And then you try to do all your work on these types of feature branches or bug fix branches, other things like that. And the main reason for that is because it's your branches that allow you to build up pull requests, which will allow you to do things like code review and other things that are standard in industry. So that's kind of where this model kind of came from. This is Git flow. So this was Beeler by person, so Vincent Drazen. So the link for this is also in the speaker notes. There's speaker slides for like all the type of stuff. And so you can kind of see there's the same type of thing going on here, right? We have some main branch that basically things only kind of go into, and then we have feature branches down here. Now, what's different is that in the previous instance, we only saw this one master branch. Here we actually have two. There's one that's also called master in this case, but this performs a bit of a different role. The more similar one here is this develop branch. This is where kind of your main development stuff happens. So the way I like to think about this is that develop is kind of like your bleeding edge, right? So the branch that I have, I call bleeding normally. And so this is where you're just going to kind of put everything as you're building up the product and certain features become finalized to the point where they leave a PR and go into kind of the main development workflow. Master is kind of where you're like in production, right? You're either making releases or you're deploying it. And so you might see something like a develop branch followed by a production branch. And so the production branch might be attached to something like Heroku or whatever. So it's pulling directly from GitHub to deploy your website. And so something like that is where you would see this type of workflow. And then your feature branches kind of do whatever. They also have hot fixes. And so the hot fixes can also go directly back into production, but they also need to go to develop. That way you make sure you get both changes. And then release branches if you're doing like multiple versions of things. The main thing to keep track of here is that having some type of, master branch that's more production and a develop branch that's, kind of more whatever is currently in progress is very common. And then naturally feature branches is a staple between both. So yes.
Yeah, I got a double question from chat.
Cool.
One is release branch for release candidates.
It can be. So in general, it's just for like any release. So release candidate, fine. If you were managing multiple versions of software, so for instance, you had like a version 1 and 2, like Python is version 2 and 3, right? Not anymore, but you did. If you were managing both of those, then you would have separate branch of development for keeping track of that, because obviously they're not the same product.
And then the second part was, will these slides be posted on Discord?
Yeah, let me actually, let me throw this in here. This is the repository for workshop stuff. So the instructions are kind of on there, but I guess you can jump into it if you really want, but wouldn't recommend it because yeah, not quite there yet. Okay. The slides are linked in there. Anything else too? The speaker notes for the slides also has reference links for some of the other things like that too. Okay, merging methods. So now we're kind of getting into things like pull requests, right? So we have this branch model, we're making pull requests, and now we need to figure out how we're going to merge this together. So GitHub has 3 options. There are other ways to do it, but these are the most common even within Git anyways, which is why GitHub does it. We'll see some of the merge nuances a little bit later, but I just mentioned these, that they are different. So you can see kind of how like the ends of these where the actual merge commits. So F1 and F2 are the things on your feature branches, right? And how those end up back into the main workflow, right? So on this normal merge, you get this merge commit here, right? You see a little circle here is this commit. After this rebase, you end up with more commits. So all these just get kind of like tacked on at the end. And then in squash and merge, right? We don't even see the feature branch anymore. We just have this one giant squash merge commit, whatever that means. We'll see the specifics for that a little bit later, but I wanted to bring it up and shit here. My recommendation is normally to use squash and merge. So, okay, commit messages, right? This is kind of hiding. Okay, that says description. It was visible. So commit message is kind of a huge thing because your commit message is basically what you can do to best describe the change at any one given point in time. Comments in code have, a lot of conflicting ideas with it. The short answer is that it's hard to keep comments in track with the code as you kind of do them. So if you're having relatively good commit messages, then people who are going back and looking through the commit history can see, hey, this line of code was changed. Why did that happen? And hopefully they can get some help by looking at the commit message for it. This is a commit message from one of my projects. And so this talks about some things that I had to do for handling, for fixing variables and functions. And so there's a few things, right? So I start with a verb, right? You always say what the commit does, not what it did do, because until this thing is like merged in, it's still, it hasn't done anything yet. So you try to write them in an active kind of tense. Then as descriptive as possible without being too long. Then it jumps into the why, right? And so basically what happened here was I had made a mistake with how I was doing, methods basically. So we know like in object-oriented languages, a method does this dynamic dispatch thing, right? If I have a different object and I call the same method on it, it'll go find that object's implementation. Long story short, I messed that up. So it wasn't going to the specific object's implementation. It was doing something else. So I had to redesign the whole system to go and fix that. And that's what this kind of explains. This also addresses a whole bunch of other limitations because I took shortcuts or I made to-dos and other things like that, things that I wouldn't quite address yet. And so when I find those to-dos, the to-dos were added in this commit. So I look at the Git history to see where the to-do was added, and it'll bring me to this commit. That's an explanation for things, right? Does that make sense? Cool. One other thing that's not shown here, because this is a direct commit, not a PR. If you have an issue and you're doing a PR for it, you can actually, or you can even do it in direct commit. You can add something like resolves #1 to basically say this commit resolves this issue, and it'll link that commit to the GitHub issue. And if that commit is eventually merged in, right, either directly or through a PR, it'll close that issue for you. That's a great way to keep everything all connected, right? That way, when you're going back through issues, you see the commit that fixed it, then you have the commit messages, and everything just kind of sticks together. Okay, a quick aside here. This is not particularly useful, but I'm going to mention it anyway because it's a pet peeve of mine. I don't like git ignore files. And the main reason why is because your git ignore file is basically saying, if I were to just try to add everything in this project to Git, what things am I not including? And I think that's backwards. I think you really want to be specifying what things should I be tracking in version control, right? Like pretty much everyone is probably, maybe you haven't made it, but you know someone who has added all of Node modules to GitHub, right? Like know that it's terrible. And part of that just comes from not being careful with that. I think it's better to explicitly add things, personal opinion. But the reason why I particularly mentioned ignore files is that it's not just personal preference at this point. If you're working on different projects, different repositories, or different languages, the things that go in git ignore file might be different. So for example, a common thing that'll happen is you have some type of repository that has a relatively basic git ignore file. Someone with a Mac computer picks it up, just does a git add, and you get all of the Mac internal folder things, which are the DS store files, right? You've probably seen a Git repository that has all of those too. So that's something you have to be careful with as well. Anyways, okay, this is where the fun begins, right? And by that, I mean this is where I break things. I think I just saw a challenge. Hold on. Where are the git or file? Or yeah, git include files. So I agree with whoever said that. The name got hidden, but I agree. Okay, history. Okay, so what the? Okay, thanks, slides. Git commits are stored as a tree. Right. So your branches are trees, they come off each other, and then they might eventually go back into each other. When they go back into each other, they do the very specific merge stuff. And so for the most part, it looks like a tree for everything that we're trying to do. Now, existing commits can be modified, which rewrites history. Okay. You should only rewrite history that does not affect other contributors, right? So like a personal feature branch or something like that. Are you that? You should only rewrite history that does not affect other people, right? Like, forget other contributors, other people just in general, right? That might even include you in the future. So depending on what's happening, rewriting history, it can be very sketchy. It's a very powerful thing to do, and there are many good reasons to do it. And there are also a number of cases where it's literally the most standard option, or it's the only option, or the best one, or whatever. That said, you need to be kind of careful because it's a powerful tool, right? So common use of history, right? So amending commits, this is a great one. Reverting things, so you can revert workspace and, kind of rebuild a whole bunch of things, or performing rebases. And we'll talk about rebases later. So history and some environment commands. I'm including the environment commands in here because you do a lot of stuff with history, and your environment is kind of like your local workspace. And so the process of that, you do a lot of things modifying your environment and what types of files or states of things you're looking at. Some things. So git stash and git stash apply. Has anyone here actually used git stash? Okay, that's about what I thought. Git stash is a super cool tool. It basically allows you to take a whole bunch of changes, basically say, go hold on to these for a quick sec, then do a bunch of things and then go fix it, right? So if you've ever been in a file and you've tried to like pull down changes and it's been like, we can't pull these because your changes conflict, then you've probably just kind of taken your changes, copy pasted them out, done the pull, then copy pasted them back in, right? Git stash does this for you, right? So if you understand the merging rules and how you can work with that, then this is a much better approach. Git checkout, git restore. So git checkout does a lot of things. Git restore is a command that does everything git checkout does. It's just named more appropriately, right? So this is how you can say basically revert whatever file this was to whatever is on, this branch or whatever, if you've made changes. There's a bunch of other things like that. Git reset also is the same thing, but it does on the entire workspace. So you may need to make use of this command in the workspace or the workshop. Just saying. Git reset does two things. Soft basically says reset whatever the Git history things is, but leave the changes that are currently happening as new changes that are being made. Reset hard means delete whatever changes you have and just bring my entire workspace back to what it was previously. So git reset -s hard is basically like the RMRF as far as like Git goes without nuking the entire repository, right? So both can be useful, just also be careful. Okay, now on to actual stuff. So git commit amend. If you've ever made a commit and you realize I made like a small mistake, right? Don't make like another commit that's like, fix the 1 to be a 2 or something like that. You can just amend the commit, right? So it'll basically say, instead of the previous commit, just do the same thing as the previous commit, but also add whatever changes that I have now on top of it too. And this is great when you're doing feature branches or other things like that, right? You don't have to be afraid of kind of making commits or intermediate commits or other things like that. If you just want to save state or have a place to go back to or other things like that, right? One way that some people kind of use this is they'll just build up a whole bunch of intermediate commits. And at the end of the day, they'll go back through and kind of like combine them and mix and match and whatever. I think that's a little overkill, but at the same time, if you get good enough with the commands, you can do that pretty quickly. So fair enough. No edit just preserves the message. So that's generally what you want to do for the small changes. If you have to do like a bug fix or something, you made the commit, then you actually went and tested it and you found something was wrong there, then you can do something like this. Git rebase. So Git rebase has a bunch of different things going on. -I is Git rebase interactive. It's very complex. So it's basically a Google it, right? Kind of like I was saying earlier. And then abort is basically like if the rebase goes bad and you just want to say done, you can abort out of that. We'll talk about rebase here later. We won't need it for the first part. And then git cherry pick. This is a kind of cool command. It allows you to basically select individual commits. So instead of like taking all of the commits and throwing them on, you can like specifically take whatever commits that you want. So that can be kind of cool. The situations for it are pretty nuanced though, and you probably won't see anything like that. That one is like actually advanced. Okay. Workshop 2A. We're going to rewrite history to fix pull request number 2. So if you have Git installed, you're more than welcome to kind of end that. I have, github.com, Anders Advanced Git. Okay. So I have this repository here, right? Leander's Advanced Git. I think I linked this in the Discord too. This has a few different things going on, right? So it kind of explains what you need to do. It also provides a few hints if you need them. I recommend giving it a few before you try. And so basically what's going on here is that we have this custom square root.py file here that's basically doing this custom square root behavior, right? And so you can see we enter some number, we call custom square roots on it, and the implementation of this is kind of to do, but we just let it do the normal math square root for now, right? So if you were around last week, then you'd kind of know where this is going. So in issues here, we have custom square root, also the good first issue. And so this custom square root function needs to be implemented. So it should return the positive or negative root depending on whether the input number is positive or negative, right? Simple enough. So in other words, the square root of 16 is 4. The square root of negative 16 is negative 4, right? Or more accurately, I should say the custom square root of negative 16 is negative 4, right? So, and that's simply because we're saying that it should return the negative root if the input is negative. Make sense? Okay. Now we have a pull request over here too. implemented by, some guy who's definitely not me, who might be me. And so basically what happens here with this custom script.py thing and a whole bunch of other things here that's doing stuff. And you can see we have some commits over here too. Now there's a few issues going on here, other things, right? So for example, here we have this commit that's fix issue, and it just kind of like does stuff. What's the issue? Right. So when it comes to writing good commit messages, whoever did this doesn't really know what they're doing as far as that goes. So the idea here is what we're going to do is we're going to rewrite history to kind of make this PR better. And so what you'll need to do here is you'll need to fork the repository. It won't let me because this is my repository, but if you fork it, you should get all of the branches and everything. And then you can pull out this branch, basically check out this feature/custom square root branch, right? And then you can use history commands in order to do that, right? There are some hints on what commands that you need to do, but so the largest things that you want to be looking for are things that can basically go back in time and do one of two things. They can either get rid of previous commits so you can make new commits, or they have the ability to change the message of previous commits, right? Now remember, so the git commit amend thing had that option where basically we did a commit, but that's only back one commit, right? In this case, we have 3 here, but 2 that are a part of this, right? And then what we're going to do is we're going to put it all together. So there are a couple of different tricks and other stuff. What I'm going to do is I'm probably going to chill for about 4 or 5 minutes. And then after that, I'll start kind of going through this. And then people who are stuck can kind of catch up as I kind of walk through it myself. And we'll go like that. Did that sound good enough? Cool. All right. So we'll probably plan to be done with this one about 7. And then we'll have kind of the last little thing, and then we should probably be done about 7:20-ish. I don't want to go past 7:30. So, okay, cool. I see something in chat here. Sounds good. Nice. Let's see. Well, I'm doing that. Yeah. Yes. Yeah.
Git is not recognized as an internal or external command operable program or package file.
Have you installed Git? So yeah, also, if you guys want to work together on things, by all means, I recommend that really. So it can be helpful to talk through some of this stuff. And also Google stuff, right? Like in this case, it's basically, how do I change the messages of previous commits, right? So you can Google that and probably find a pretty good response, right? Perfectly valid thing to do. Key thing is at the end of the day, understand the commands that you're running and how they work. Fair? Right. Nice. And be ready. Yes. Seems like Benjamin is having some fun with the GitHub CLI. So Yeah,
I just had to do that because command prompt and PowerShell weren't working for me, so.
there's a lot of things. If you install Git normally comes with Git Bash, right? So if you didn't do anything special, you have Git Bash available. And this works for a lot of cool things.
I actually use Git Bash for OS when we're working my book program, so when you're OS.
Here do I have LS? Yeah, advanced Git, nice. Yeah, so this is pretty good for things, right? Okay. Cool. Yeah, Git Bash is pretty effective. The nice thing about Git Bash too is that because it's like a standard shell that just comes bundled with Git, all of the commands do the exact same thing. So you don't have to screw around with things like PowerShell being different from command prompt or, terminal on Mac and, or having to download like Windows subsystem for Linux or something. Okay. All right. Online people, feel free to message me if you have any questions. I'm going to walk around the room clear. Okay. All right. You guys got progress. Do you feel like you know where you're going right now? Okay, good. All right. Do you feel like you know where you're going?
I know this part already. So want something else.
Okay, that's fine.
Yeah. I'm here to learn about the words.
Yes, come on.
Right now, we're trying to respond to all right.
Okay.
Start slow. Okay.
So.
If you punch your head from me, so where that
Works thing. So, okay, so to be able to make a PR to things, but you're getting, so you can press things, but if you want to make a PR back to things, we'll need a fork. Right. So do you fork things?
Oh, thanks.
So over on GitHub.
Yeah, we just work with
So up at the top right. Yeah, I can maximize it. Well, it's in mobile mode right now. Yeah, fork. Great. So, and then you can fork it to your account or local accounts. And so now this is your repository. So you can literally do like you can rewrite the history of my repository because it's yours now. GitHub won't like it, but you can do that. So like there's literally so GitHub has security is vulnerability where like you could literally just change the author and GitHub will like link it to the email for whoever had that email on GitHub. So like there's places where like so like Linus Torvalds is like committing to random repositories and stuff. It's great. So and it like shows up in his contributions and stuff too. So I don't know if they fixed that yet, but okay, good. So now you want to clone this, right? Okay, so you have it in this file. Right. So put it in advanced Git, so CD into that. And CD advanced Git. So you can tap and put two. Right, and so now you're so you can start running your bits. Right, so the first thing you'll need to do is to switch over to whatever branch that pull request is on. Right, then the second thing that you'll want to do is move up from it. You could.
I'm trying to figure out the UI.
Okay, yeah. So interactive rebase is a bunch of kind of crazy stuff going on with it, right? So the simple thing is that you find okay, so there's a link that has some info. Basically just search interactive rebase. And that's the easiest way to figure out. Because what you're going to do is you're basically just going to say, I want all of the commits, but in the process, it'll ask you if you want to change the message. That's what you so now the other thing too is that like you can also like, you don't have to basically say, I want to do all, right? You could just clean up the commits depending on like how you think that one constructor works.
Okay.
Right. So there's no right answer to this, right? There's more than one way to do it. It's a matter of messing around with tools and seeing what you can kind of figure out. So I'll probably do the single commit one mainly because we'll do rebase next. How do you do it? Yeah. Okay, so :Q and :WQ saves. So So colon is like command mode, basically. And then Q is quit and W is write. So WQ is write and quit, which is basically save and close. Okay, so yeah, so we're in insert mode now. So Vim is super nonsense, really. So what you're gonna do here, so basic Vim was you have a command mode, right? And then you have a edit mode, insert mode. And so right now you're in insert mode, so you give a state. Right, so, and that should bring you out. So, okay, try colon. So colon.
I didn't like, I'm not sure it's their pocket.
Okay, so can we type in here right now? No. Colon. Wait, did you hold on? We'll get to close out here. Sorry. More about here. Oh, what the heck? Oh.
I'll put you back into the both you.
No, now, okay, it's a whole bunch of text down there. Now I'm in insert mode. Let's just quit. No reasons last one. Okay, it's fine. Okay, we're out. And then you can abort that if you think you messed something up, but it said it didn't seem to change anything. I think what happened there is that the PowerShell window was so crazy, we couldn't figure out what mode we were in at all and just entering random stuff. Yeah.
I've squashed the commits into one, but I'm not quite sure.
Cool. Okay. No little time schedule here. Let's see. So we're not implementing the functionality, Benjamin. The functionality is implemented. We're just trying to clean things up a little bit. So we'll take a look and see what we do that. Okay, so I'm going to kind of get started with things. So there are kind of two main ways that you can do this. So one is if you want to just, let's start by identifying what things that we want to kind of change about this, right? The largest things that we can see that we want to change here are that we have just the messages really, right? We just have this fix issue. That's kind of the worst one because this means absolutely nothing, right? So we want to do something here, right? So we can see like we're changing some import stuff, but we also have this thing, right? So we're doing this nan thing. That's probably a pretty good thing to mention. There's another thing too, which is that why is this math.isNan, right? And the reason is because nan is not equal to itself. We have to use this isNan method. We can't do something like if number equals nan, right? Because that won't work, right? So things like this are pretty good things to call out in the messages. There's also another small nuance here, but we'll get to that in a quick second. Okay, so back over here, what I'm going to do is run git log. I think I'm on the right branch, right? So I'm on the right branch here, right? So we can see all of these. So one way is with git rebase, right? We can go back and basically say we're going to rebase onto, do the same things, but what we're going to do is we're going to change the messages in the process of doing that rebase. Rebase is just more powerful than what we're using it for in that case, but it's one of the things that rebase can do. And naturally, rebase is a very useful command. So if you get comfortable with that, then using that powerful command to do message changing is pretty straightforward. However, there's another way, and I'm going to do this because we'll use rebase here. So this way is basically what we can do is we can say, just get rid of the entire Git history for these two commits. And then we're going to basically be left with the changes, and we're just going to combine them into one commit. Right? We could do two if we wanted to, but these are pretty small, right? It doesn't seem like it's particularly useful to kind of highlight that, right? This fix issue thing was basically like an afterthought, right? So it's not like there's this giant kind of overhaul going on where it might make sense to kind of separate that out. That's just a judgment call that I'm kind of making to save me some time and allow me to show some of this stuff too. So what we can do here is we're going to actually use git reset, right? And so for Ember, we have git reset hard and git reset soft. Which one do we want to use here? Do we want to keep the changes that are happening here?
Yeah.
So which one do we want to use? Right. So we're going to do git reset soft. And now what we want to do is you want to reset this branch to the point before these commits were made. What I could do is I could basically copy the commit message. I think it's this one. Whatever commit message, it's this one. Whatever commit number, so enough that it can identify the point. The other thing I can do is I can basically say, I can reset with head. And so head is basically the current point in that branch. And then what I can do is basically say head and then whatever's previous by that by 2. So in other words, git reset soft head 1, right? This is a useful command to know, right? Can someone tell me what this command does? Yeah.
Goes back one commit without deleting change mids.
Right. It literally just removes the last commit from Git history, right? It keeps all the changes, everything you have in your workspace, nothing came to there. It just literally just removes the last commit. Super useful. In our case, we're just going to go back to instead, right? And so now if I run git status, right, what I'm going to see is I have this custom script.py. I don't know what this thing is. So I don't really know what that is. We're just going to delete that. I think that's something that Notepad++ is doing. So we don't need that. Okay. So now we have this custom script.py, right? If I do git diff, we don't see anything. And that's because this is already added. So if I were to say git restore -- staged, so custom script.py, and now git diff, right? Then I see this, right? And so these are the changes from both commits just kind of combined into one. Okay. So now what we're going to do is we're going to actually make this into a commit. So I need to re-add this file. And then what I'm going to do is git commit. Now we're familiar with the -m, right? To do the message here. What we're going to want to do is we're going to write a bit longer of a message. And so I'm just going to do normal git commit. And this enters us into Vim. And this is where the funny is. Is it Vim or VI? I'm not actually sure on PowerShell. So probably neither and just something. Well, it is Git, so probably one of them. Okay. So the way that this works is that there's 2 modes. One is insert and the other is basically like a command mode, right? So right now we're in kind of like command mode, right? And so if we want to actually go in and start modifying this, we need to press I, right? And so we see that we have this insert pop up. And so now we can start typing messages. So in this case, we want to describe what this is doing, right? And so at its core, this is basically now that this is both commits in one, we're basically just implementing this function, right? We could like do more specifics or other things like that. Too bad. But I'm just going to say, so implement, so custom square root. So to return negative root or negative root. Right. Okay. So you can see this doesn't like how long this is. So I'm just going to leave it as is. If it yells at me, it yells at me, but I'm not going to go crazy about, the specific formatting things. The point is to demonstrate the idea. The other thing is, this is implement, not like implemented, right? And what we're going to do is basically say, so this, so negative input should return a negative number. So should return, let's say the negative root. So the negative root. So if the input is nan, then an exception is thrown. Okay, cool. This is probably good enough for the changes that we had. There's not too much going on here. We're just trying to explain this. Now, if the input is nan, then exception is thrown. This kind of just blatantly describes the code. So maybe there's something else that we could say here, right? So let's see. But is nan, then an exception is thrown. Exception is thrown. And now we want to also add in the check for nan. must be done with math.isNan, since nan is not equal to itself, right? And so this is just a basic description of what's going on there. Now, in practice, this is probably overkill, right? And in reality, this really is overkill. Most of this is pretty straightforward as far as what the specification says for it should do. The important thing here too is that like the check for nan with math.isNan, as you get more experience, this is kind of a relatively known thing. So for this level, right, if you're working with like other students who may have like never heard of nan being an actual like floating point number, then this might be a very good thing to include because they might look at that and you know, do weird things with it, right? In industry, you know, the types of comments where you need explanations are going to be more the higher level architectural things and not the nitty gritty code levels. This is just demonstrating the idea. Fair enough? Cool. Okay, there's one last thing we can do. Anyone know what that is? We have this issue here, right? So, someone did it. Who did that? Nick?
Yeah.
So explain what you did.
I used the interactive rebase to squash the commits into one, and I just made a pull request on my forward repository. But I mentioned your that commit in my pull request, so I think that's why it's showing up.
There, right? Resolves number one, right? So if we do this, right, resolves number one, Git is going to link this to the issue. Okay, so now that we're in here, so to escape, we can do escape and then colon WQ, we can save. And so now we have this. So Git status. Now, your branch and origin feature custom screwed have diverged and have one or two different commits respectively. Okay, so now we have rewritten history, right? So we have our branch, which has different commits on it from the remote branch. The only way this is resolved is if we tell Git, we need to discard everything over there and take the one that we have, right? And so the way that we have to do this is we have to do a force push, right? I'll write out -- force. So -f also works, but writing it out can sometimes be helpful. Also, write out flags and scripts. Don't use abbreviations and scripts. Bad thing to do. So git push -- force. And so now we're going to, I think we're just on the right branch already on my case. So I can just run this. This should be fine. This is going to overwrite the history. So let's actually watch Git kind of take this. Oh, no, go. It's that one. And then we'll actually take a look and see this one go through. Right. Okay. Force push, right? So now we have this commit, right? So now if you look at file change, what happens? This is the same. Commits, right? We had 3. So now we have 1 less. We also have this commit here. So this is kind of the last trick thing. I kind of let this here as like a maybe someone will notice it type of thing. There's one other weird thing going on in this PR. Does anyone know what that is?
You have the commit to create that file also in the bleeding branch. So if you like squash that into one commit, then like there'll be a conflict.
Yeah. So that's basically it, right? So the typical thing is that this is targeting the wrong branch, right? So master is like our production branch. We don't want to merge things directly into production. We want to go to bleeding, right? That's not bleeding. So we want to go here. And if we change base, right? So it should realize what's going on here. Right? So, and now I have 1 commit. And if I look at my change log, this looks accurate. Right? Everyone tracking? Okay. So what we kind of did right there was actually just basically a rebase, right? It just kind of like ran a mini rebase behind the scenes as far as like what it was thinking was going on. Okay. However, if anyone saw me kind of messing around at the start, I also created this one. And so this is another little PR. This uses a thing called argparse. So Python has a library called argparse. By library, it's a built-in thing, but it's a library that can be used to parse command line input for things. And so this does things like validation and other stuff like that. I thought it was a good thing to show, and I needed something else to add in here. So hey, why not? So what we're going to do is we're going to merge this in. And so when we merge this pull request, right, you can see we have 3 options. Merge commit. all of them will be added to the base branch via merge commit. So it's going to take all of our changes. So it's going to take all of those commits and basically link all of the commits together with one mega commit that contains all of them, right? Now, by that, I mean more like it's not going to have all of the changes per se in one. It's going to basically be a commit that says, here are all of the commits that are included here if you want to go look at them, right? That's a weird distinction, but that's what it does. Squash and merge is going to take all of the changes and do one. And then rebase and merge is going to take the commit and it's going to apply it directly on top. We literally only have one commit. So these two are actually the same. Merge commit is different. As said, squash and merge is generally nice. The pull request will track the history of branches and other stuff like that. So if we want to see like what types of changes and other things like that has gone on, we can look back at the pull request, which will be linked in this. And so squash and merge is good for this type of stuff. So you can see it's doing some other stuff, right? It's pulling that over. We're going to confirm squash and merge. Okay, now it says we can delete the branch. Yep, we're going to delete the branch. We don't need that branch anymore. And there we go. Okay, so now we have input values with arc parse from pull request number 3, right? So you can see it's linked here in the commit. So if I want to go back and see what's happening, we can do that. Okay, now. I mean, we shouldn't be saying yay, but I'm just glad that it worked. We have merge conflicts, right? What did we do? We added a pull request that modified things and those modifications overlap. So let's take a look and see what Git thinks they are. Okay, we can actually jump back to slides for this. We're a little over time, but that's okay. We'll go quickly. Meow. Oh, wait, no, we were in the right place. Okay. Actually, before I do, any questions on this one? Right. Okay. Quick feedback question. Was that too open-ended? Was there not enough guidance for people? Did people feel lost? Or was that kind of like enough interesting kind of problem to get into? So be as harsh as you want. I don't care.
Hard, but I don't like. I have trouble interpreting the question myself. So, but I think that's just from my own inexperience with Git. So like I know the basics. I know the basic structures, and like so like I'm being in the other room with before and probably. But like here, it's like it's not a huge gap. It's just like I haven't used enough to really understand.
Gotcha. So be more specific with what should be done there. Okay.
Yeah, I don't think it's your fault.
Did the hints help with that? Because the hints tried to provide a bit more direction there.
We actually looked at the like very last. Like we do check it.
Fair enough. But, so if you have anything else, let me know. Yeah, no, perfectly fair. Okay, I see chat message. Yeah, experience. Okay, cool. All right, merging. So merge conflicts. The first sign of the apocalypse. I hope I spelled apocalypse right. We're going to go to the next slide before anyone can check. Okay, so merging is used to combine two separate commit trees together. So as mentioned, if we have two branches, right, this is a tree-based structure. So in order to take those trees and combine them together, we need to figure out some way to manage any type of conflicts that may occur. Right. And so these merge conflicts are what happens when the changes overlap. We have to resolve these manually, right? There's no automated process that says take this code, but not this code, right? Like we're not at that level as much as GitHub Copilot would like to think that we are. The fewer of these, the better, obviously. Fewer merge commits are good. And then a rebase is one approach to resolving merge conflicts. And the way a rebase works is it takes all of the changes and it basically applies those changes step by step on where you're trying to merge onto. So in other words, we'll see a diagram later, but yeah. Okay, few diagrams. So a few types of merges, really two. So one is a fast forward merge. So a fast forward is basically there are no conflicts and we pretty much don't have any actual issues, right? Because the branch that we came off of hasn't changed at all. So what we can do here is we can basically just say these commits just literally move over and become part of this branch, right? So there's no fanciness, nothing else, just these commits go over here. Now, if we have to do a merge commit, right? So like in this case, we can see master gets an additional commit on it after the branch was created, right? So in this case, we have to do a merge commit. And the merge commit is basically what says, make sure that these two kind of fit together, bundle these up, do the commit things you need to do, link them together, and whatever comes out the other end works, right? Now note that this is like not a merge conflict thing. This is just strategies for what the end commit thing looks like. In general, fast forward merging is generally not as good because it kind of like hides this branch that used to be there. No fast forward is generally, I would say, better, but merge conflicts can kind of have their own problem. Merge commits can kind of have their own issue too when it comes to looking through history. So if you're doing the standard PR thing, then squash and merge is the option there. Okay, so this is what a merge conflict looks like, right? So in text, you will see something that looks like this, right? So we see basically, so head, right? So head is whatever branch is looking at, right? And then we have this code and then a separator. And then over on the develop side, right? So we have, so this person is practicing good Git flow, right? So they have some develop branch that they're working with. And so that has, these different URLs. And so what's probably happening is both of these just need to be combined, but it doesn't know, do I combine the code? Do I replace one with the other? What happens? And so we need to specify that explicitly. And the way we can do that is just clean up so that this looks right, and then just remove these things, right? And Git will figure it out automatically for us. Now, a rebase is similar, but this changes basically where the original commit was. We kind of built this feature branch. And what we're going to do is we're going to say, for all of these commits, let's pretend as if we were applying those commits onto wherever the new, master branch is, right? And so what happens is we get new commits that basically are almost exactly the same, but just have those clarifications built into them. So think of it like this. It's basically like, if I were to build this feature at the time when I knew about these changes, then I would have gotten rid of the stuff I knew I would have gotten rid of, and there wouldn't be any merge conflicts. And so that's basically the idea here. Okay, so now that I've broken all these PRs, what we're gonna do is rebase them. And so there's a few things, but Nick, maybe you give this a go. So we can take a look at what your PR looks like and see. Also, we can see this is what things look like, right? So we have our standard merge commit kind of looking thing here, right? So let's see. So we had this issue, and this had this, right? And so we can link to this one, right? Okay. So now, let's see. So this into bleeding says commit, and then this is probably running into a merge conflict. I just can't see it. So if you want to look into trying to do the merge conflict for that, then we'll merge this one in here. So in the meantime, just for the interest of time, what I'm going to do is I'm just kind of get through it. So let's see if I can get these command rights. So git status, we are on this feature custom square root. So I want to git checkout bleeding. So I am up to date with origin bleeding. So this is where it can be misleading. This origin bleeding is my local one, right? It's my local copy of the origin remote and the bleeding branch. So if I actually pull here, right, I'm going to get this commit, right? So this is a very weird thing, but just remember that this is actually a thing, right? And that's simply because the only way it'd be able to know if it's up to date or not is to make a whole bunch of network requests. And that's not exactly, distributed VCS. Okay, so now we have bleeding up to date, and I want to check out our feature. Let's see, origin feature. Oh, wait, yeah, I can't tab complete that. Git checkout feature. Okay, so here's another thing, right? So as I said, checkout is overloaded, right? You can check out like individual files, other things. There are new commands added. One is restored. The other one is git switch. So I still can't tab complete. That's fair. Okay, so I can use git switch to feature / custom square root. Okay, so now I'm here. And so what I want to do is I want to git rebase onto bleeding. And let's hope I have this in the right order. So, okay. So could not apply this automatically, right? There were conflicts, right? We were expecting merge conflicts. This makes sense. So let's go actually take a look at these. Is it using Vim? What's it using? So let's try VI onto custom square root. So no, it doesn't like that. Okay, we're going to do Notepad++ because I like Notepad++. Okay. All right, here we go. So here's our conflict, right? And all we need to do is just fix these, right? So we're just going to make this look like it should at whatever point this is. We could do it where we make it look like the final version, or we could kind of try to do an iterative type of thing. So the intermediate one, you know, might be incorrect, but then a later commit comes in and fix it. Doesn't much matter. We only have one commit here anyways, right? Okay, so obviously we need import argparse, right? Then instead of this math import square root, right, we have import math because we needed to actually access math that is nan. So we ended up like this. Okay, first conflict done. Second one. Okay, we want to keep all of this argument parse stuff here, right? We want to keep this print. We don't need any of this. However, right, one of the things that was changed is we were taking the number from an integer to a float because we wanted to use decimal values and stuff for this, right? That was just kind of a personal choice to demonstrate this so we could get an actual conflict. But we're going to change this from type equals int to type equals float, right? And so now we can clean all of this up because everything else is as it should. Okay, so we can save this file. Let's actually run this. So let's see. Someone give me a number.
7.
7. Okay, does that look like the square root of 7? I think that's close enough.
Yeah.
All right, someone give me a negative number. -7. Okay. Fair enough. All right, now let's try something else. Let's try the square root of, let's say, infinity. Okay, square root of infinity is infinity. What about the square root of negative infinity? Aha. Let's try putting that in quotes. So, wow. It doesn't know how to do that. So this actually seems to be something kind of odd in argparse. Maybe it's not set up. I actually don't know how to give this a negative number. Or a negative infinity specifically. Well, if someone wants to file a bug for that, feel free. I'm not. Let's actually try nan. Right. So exception invalid number, right? This is coming from the invalid number exception we built in, right? Okay. So everything here looks like it's working fine. So if we run git status now, right, we can see we're doing an interactive rebase in progress. We're going on to this commit, which is your main branch. And then, so basing this, yada, yada, conflicts. And so now what we need to do is if we have git status, right? So both of these are good. And it says use git rebase, where is it? Git add to mark resolution. So git add custom square root.py. So now if I do git status, that's good, right? So we're all good here. Git rebase -- continue, right? And so now we get to basically do the message. In our case, the message is the same, right? So we can just immediately get out of here. Did I select another thing? Where am I? I can't tell where I am anymore. Okay, somehow we got into insert mode.
Might not be relevant at this point, but that if you add a leading space to negative infinity, it might work.
A leading space.
Yeah.
We'll try that. I'm too curious to not try that.
Leading space within the quotation marks. So
Okay, PowerShell is doing super weird things. There we go. WQ. Okay. Get log. Let's make sure the commit wasn't. Okay, the commit was totally butchered. So what are we going to do? So literally unintentional. But git commit -- amend. Right. And now you can go in and actually fix this. Oh, insert. Right. Clean that up. Clean this up. Right. So I swear that was unintentional, but it worked out well. WQ. Right. Okay. So now we've cleaned that up. Fair point. Right. Okay. Q to get out of that. Get push. What's going to happen? Why is it erroring? Well, what did we just do? We changed the heck out of history, right? We just rewrote a whole bunch of commits to basically change where they're all pointing to. So everything about this history is different. So the only option we have is to force push, right? So we double check to make sure that we're good. This is a dummy repository, so it's fine anyways. But we check to make sure that we're all good. We want to make sure that we're on the right branch, right? So we're on our feature branch. So worst case scenario, it's only going to RPR. And so we're not going to mess up any type of major things. And so git push -- force. Right. So, and if I go back and take a look at our pull request over here, no conflicts, right? Now I could squash and merge that, but I want to see if Nick was able to get your merge conflict resolved. So did you get it?
Yeah.
Okay, let's try to merge yours in. So this.
It's just a pull request from my request.
Oh, you did a pull request from yours to yours. Okay. Do you want to recreate it and then send it on to mine?
On the last page, oh, never mind. That was just a tag saying that my pull request is open, but it looked like there was a button to one, but sure, yeah.
Yeah, you do that again quickly.
I can just edit,
So yeah, if you edit the target, I think that might work.
it's not letting me pick a base branch from your repository.
Gotcha. You might have to create a new one. Yeah, you should be able to open a pull request to any repository over GitHub without permissions. So it's just an inherent permission. We'll see. Okay, let's run that weird Python thing. Where are commands for that? So what did someone say? Space negative infinity.
Yeah.
Oh my. Who said it? Who said it in chat? Okay, Ben, I don't know how I feel about you anymore. I'm glad that you knew that, and I'm also very annoyed that you actually somehow knew that. Okay, you Googled it. That makes me feel better. Okay. No, it's all good. So kudos looking into that. This is an example of absolutely terrible input parsing. Just saying, right? So because my guess is that if that's the case, it's trimming the input. So I can do this. I might even be able to add in a tab. Invalid. Okay, didn't like the tab. That's fair. So, oh, because that's happening at that level anyways. Yeah, so it's just doing whatever. If I could insert a tab, I'm pretty sure it'd be fine. So it's probably argparse trimming the input. So come to think of it, it's probably argparse doing that. I guess it's doing something to try to special handle the flag, but that's very interesting. So, okay, anywho's. So let's see. So
I made a pull request, like your bleeding custom square root is ahead of mine. I don't have the art part stuff in there, so I would be downgrading it.
gotcha. Okay, fair enough. We'll do is we'll just put that in. Does anyone have any questions on things?
He has a couple more questions with that.
Sure. You want to read out?
Yeah, so is Git
Swap and merge?
a replacement for Git checkout brand?
Yes.
Okay.
So, well, so Git checkout and then the branch name, because Git checkout does two things. It updates a file from a branch if you give it a file name, and it switches the branch that you're on. So what they did is they split Git checkout into two commands: Git restore, which does the file path, and then Git switch, which does the branch. Use whatever you want. A fun thing though is that Git checkout -b will create a branch if it doesn't exist, and I tend to find that faster. So the other thing is that I think that the Git switch stuff is more recent, but at the very least, what I originally learned was checkout. So that's where my muscle memory is.
And the second question was, is the big difference between rebase and merging that rebase just fast forwards the commit it's based off of instead of actually merging the code back into the base?
I'm gonna need to look at the wording of that a little bit more carefully.
Yeah, that one.
So rebase doesn't merge anything. So it doesn't merge anything, but it can't fast forward it because fast forward is by definition, right? Like there are no other commits or anything. So like you can make a merge commit that's not fast forwarded, and you don't have the option to fast forward without there even being a merge conflict, right? You can also do rebases without there being merge conflicts either. Rebase is basically just saying, take the changes I have and apply them to something else, right? So like your changes, your commits are like layers, right? Like if you look at git diff, right, it's just text differences. And so what it's saying is that take those differences in text and just instead of applying them on whatever this commit was, apply that onto a different commit and see if that makes sense, right? And that's basically how it works. So I think that's probably about the best I can explain it, really. So, okay, that makes sense. Perfect. Okay, so one thing that I did, notice I did this with a merge commit instead of doing squash and merge. So we can actually just take a look at the commits to see the difference and what those look like, right? So you can see this one was our squash and merge, right? So it looks like the normal commit because there was only one. This is the merge commit, right? So merge pull request number 2 from this branch, right? And so if I guess I can click here for that, right? We can see this, right? And so we can see everything that was going on here, right? So they do similar things, just the message is a little bit worse. But like rebasing can be a mess if you're like have a very complex rebase because you have to go one by one through all the commits and address conflicts. So if you're like refactoring things very heavily, then a merge commit might just be like the easiest option. So another thing you can do is instead of rebasing, you squash and then rebase, but that kind of just defeats the point of having like a separate branch for everything because then you lose that history in the process of doing the squash. Personal opinion. Okay. That is all. I do need to throw out a couple of quick announcements to y'all. Next week, there's a Minecraft social. So I don't know why, but there is. So we will have fun with Minecraft. After that is Career Showcase. There are volunteers needed for that. I didn't get the message personally. I got it from grad student stuff, but if they're looking for undergrads, that is a great opportunity too. Like if you're not actively looking for an internship coming up this summer, being a volunteer is probably easier. And you could also take a risk and say, I'm going to be a volunteer if I am looking for an internship, because it's a good chance to go and like talk to these people one-on-one before anyone else in the room, and they don't have anything other to do than to talk to people, right? So I volunteered for Career Fair for probably like 4 years now. So it's been a great experience. I would highly recommend it if like, you're a freshman, sophomore, right? Freshman might be a little bit more sketchy, but if you're sophomore and not actively looking for an internship, perfect time. And then after that is Swamp Apps. I think applications are still open and open until the 23rd. Okay. All right, cool. All right, slightly over. I apologize for that. So thank you guys so much. If you have any other questions, comments, feedback, feel free to stick around. I will pause the recording here once we're good on any type of questions or things. And I think we're all it. So cool. Okay. I think that was a bit chaotic, but
I think there's a question in the chat for you.
merging is hard. For the career case, easiest way is to email Christina Sapp. So klsapp@cisc.edu, I think. So
Cool,
I
thank
think
you.
that's the right email.
I emailed her like 2 weeks before the fall one, and all the slides were taken up. I don't know if they're still.
It's hard to say. So the other thing is that like, so I know at BS1 there were a lot of like new master's students and other stuff like that. I think one thing is basically like, hey, I'm an undergrad. I'd like to volunteer and like be around for a bit, because she's probably looking for like a couple undergrad-esque people to help kind of take charge of things. So, because previously that was me and I'm gone at the end of the semester, right? So she's probably looking for a few undergrad people to like really help out on things there. So that's
Also,
how I got this umbrella.
I have an email from the
See?
BI
There you see it.
advising that it has a form for signing up to be a volunteer.
Oh,
And
There it is.
you
yeah,
should send that in the Discord.
Computer science
yeah,
and
sure,
engineering.
I'd love-
Are you saying that?
I have a link to a form to sign up to be a volunteer, so I'll send it in the discussion or opportunities.
Cool, thank you.
No problem.
Cool. So you're welcome, Angel. Hope you got something out of it. So let's see you, mate.
Have a good day, everyone. Thanks for the presentation.
Good night.
Of course, happy to.
Bye.
I'm honestly just so glad that like the merge stuff didn't totally break down. So I was really scared that was gonna happen.
So the first thing I'm gonna say is thank you.
So you guys, you good? So some things, if you have any irritating things, like let me know. So,
I use Git in a different way, so. It's like,
Git depends on, like, when you show up to an internship, they're gonna tell you how to use Git because most people don't know how to use Git beyond like your standard accurate push, right?
Right.
So if you walk in and be like, I know what a rebase is and I've at least seen what happened, they're gonna be like, great. So yeah, so it's a fair thing to do around and get some practice with. So no,
so he doesn't like.
yeah, like honestly, this thing, use standard Git flow whenever you have like a software engineering type of project and things. And whatever happens, happens, right? You don't need to go super out of your way to try to do some of that crazy stuff.
Right.
So, but if you use it as normal, like you will run into cases where you have to rebase. And, you know, if you're managing multiple, some people like only do one thing at a time, others kind of have multiple workflows. Depends on what, but like if you're doing some multiple stuff, you will run into a case when you do rebase and other stuff.
Right, okay.
Cool. All right, and what's your name? Alex. Okay, right.
I'm just like,
I have a hard time, right? I deal with Matt and everything else. So
don't worry about it.
cool. All right, I'll see you guys. So cool. We'll pack everything up here.
Oh, thank you, because I feel like I won't just go chopping in with anyone.